Hello. So welcome back. In this lecture, we are going to discuss the third sorting algorithm, insertion sort. Okay, and insertion sort is also an iterative sorting algorithm. So what it does is it divides a list into a sorted sublist and an unsorted sublist. So we will see. Okay. And because the name is called insert, so it's going to insert items from the unsorted sublist into their correct position in the sorted list one by one. So because of this, it also does a similar thing. It's need a nested loop, okay, for the implementation. So the outer loop, it keeps track of the element to be inserted. So basically, this element, we call it a key. So keep that in mind, key, okay. So outer loop is to try to get the key to its correct position in the sorted part sublist. Okay. And what the inner loop does is to search for the correct position to insert. Okay. So that's why, because it search for the correct position is it to put, so to insert. So that's why we call it insertion sort. Let's take a look at the example, okay, to have a better understanding of how insertion sort works. So for insertion sort to work, the outer loop start at the second element, and we call it a key. Okay, and what it does is, so the outer loop, the key will move each time it advance by one, okay? So that's what the outer loop does. And for then for the inner loop, what it does, the key then will compare all of its predecessors. Here we have a concept called predecessors. So predecessors are all of the items that located ahead of the key item. Okay. And then what the inner loop are going to do is it's going to compare the key with the compare key with the predecessor, with its predecessors. Okay. And if the key is less than the predecessor, then we have a temporary variable. We are going to record it. So in this case, 35. Okay. And we also have a index variable. We call it location. And that's going to keep track of that we are going to do backward, okay, to keep track of where the correct location is supposed to be, okay. So right now it's at the index 1, okay, index 1. So we are going to compare, okay, in this case less than, okay. So then what we are going to do is we are going to right shift. So if it is less than, then the predecessor needed to do the right shift one location. Okay, so this case, then 69 will be right shift to the location. Okay, to the location. And then what we are going to do is, because then we are going uh, to backward the location by one. So move location backward by one. So then its index, basically it's decrement by one. Okay. So minus minus is a decrement. Okay, so then location updated to 0. Okay. So after that, okay, there is no more predecessors. Is it? So, okay, we have this location. Find the location where the key is supposed to be. So then you put the key to its location. So 35 is being put to the location. Okay. So after that, you can see this items, is it? This item is in its right location at this point. Okay. So that's the end of the first iteration. Okay. Then starting from the second iteration, we are going to advance key to its next item. So it's 18. Okay, 18. And then what we are going to do is we are going to, so for the inner loop, we are going to start to compare with its predecessors. This time you have two predecessors, is it? Okay, clearly it's less than, is it? So now this temp variable is going to be updated to 18. And because it's less than, is it? And we also keep track of the location at this point, it's 2, is it? And because it's less than, so you need to right shift its predecessor by 1, okay? So 69 is moved to 18. So now this is updated to 69, is it? And at the same time, the location will be decremented by 1. So it's updated to 1. Okay. And then you compare the temp. Temp is 18 with its next predecessor, is it? So it's 35. Okay. So 35 compared with 18, so it's also greater than, so it's going to be advanced by 1 position, so it's 35, right shift, is it, to 1 slot, okay, no more predecessors, is it? So now you can move your location also updated. So now you put back your key 18 to its right location. So it's 18. So now we see these 3 items are kind of, not all of them, but kind of sorted. Is it? Okay. So for the next iteration, then we advance our key to the next one. Well, then in this case, 87 is the key. Okay. So it's the key. And the same thing, then you need to compare this key with all of its predecessors. So with the first one, then clearly you find it's uh, it's greater than, so we don't need to update. And then compare with the next one, no need to update. And compare with the next one, the predecessor, okay, no. So then all of its predecessors are in their right location, So in this case, no uh, right shift, and no temp and the location be recorded. Okay, so then for the next iteration, then we can keep doing like this, So you advance the key. So this time 50 is the key. Okay, with 50 the key and all of the items are the uh, predecessors. Okay, so let's keep 87. Okay, we keep track of it. Okay, so now you need to compare the key with the predecessor. So it does less than. Okay, so now 10 updated to 50. The location is 0, 1, 2, 3, 4. It's a 4. Okay. And then we need to do the right shift. And then so 87 needed to right shift to here, okay, to the 50 position. Okay, so it should be 87. And then this 10 key needed to be keep compare with the predecessor. It's still greater than, so you do the right shift. Okay. And no more right shift needed, is it? And at the same time, location keep updated as a backward decrement by 1. So now it's updated to 2, is it? So after that, then you just put the temp to its location. Now we finish this part, so it's also sorted. And then you can keep doing with you advance the key, keep doing like this. And finally, 58 and 79 will also be inserted into their correct position. So basically, we can see for each iteration, okay, each out loop, is it? And the key the key will be moved, but it's not at its right locations, but it's will be moved to the sorted list. At the sorted list, sublist, it is at its right location. Okay, so that's about insertion sort. So this time it's mm, the key thing is you keep track of the key and also compare key with its predecessors. If it is less than the predecessor within the interval, you need to write a shift of the predecessors one location after the end of the right shift, then you put back the key to its right location at the sorted sublist. Okay, so that's the whole idea about insertion sort. So similar for the implementation, you can check the textbooks coding implementation implemented using array. Okay. And also from our discussion, you can also see that insertion sorting algorithm implementation may be a little bit more complicated than the previous two sorting algorithms. Okay, and then next, okay, this is for some fun. Okay, so this is some national park, and you can take a guess to see if you can find which national park this is about. Okay, and here is also a video about this national park. You take a look and then see if you can find which one it is. It's very pretty, okay, this national park. Okay, so that's the end of this lecture. The answer, what is this national park? When you complete all of the videos for this chapter, you will find the answer. Okay, bye.